Texas Instruments Inc. is an American electronics company that designs and makes semiconductors, which it sells to electronics designers and manufacturers globally. Headquartered in Dallas, Texas, United States, TE is the third largest manufacturer of semiconductors worldwide after Intel and Samsung, the second largest supplier of chips for cellular handsets after Qualcomm, and the largest producer of digital signal processors and analog semiconductors, among the wide range of other semiconductor products, including calculators, microcontrollers and multi-core processors. Texas Instruments is among the top 20 semiconductor producing companies in the world. Texas Instruments was founded in 1951. It emerged after a reorganization of Geophysical Service, a company that manufactured equipment for use in the seismic industry as well as defense electronics. TE began research in transistors in the early 1950s and produced the world's first commercial silicon transistor. In 1954, Texas Instruments designed and manufactured the first transistor radio, and Jack Kilby invented the integrated circuit in 1958 while working at TE's Central Research Labs. The company produced the first integrated circuit-based computer for the U.S. Air Force in 1961. The handheld calculator was introduced to the world by TE in 1967. In the 1970s and 1980s, the company focused on consumer electronics including digital clocks, watches, handheld calculators, home computers as well as various sensors. In 1997, its defense business was sold to Raytheon. In 2007, Texas Instruments was awarded the Manufacturer of the Year for Global Supply Chain Excellence by World Trade Magazine. Texas Instruments is considered to be one of the most ethical companies in the world. After the acquisition of National Semiconductor in 2011, the company has a combined portfolio of nearly 45,000 analog products and customer design tools, making it the world's largest maker of analog technology components. In 2011, Texas Instruments ranked 175 in the Fortune 500. TE is made up of two main divisions: semiconductors and educational technology, of which semiconductor products account for approximately 96% of TE's revenue. History: Texas Instruments was founded by Cecil H. Green, Eric Johnson, Eugene McDermott, and Patrick E. Haggerty in 1951. McDermott was one of the original founders of Geophysical Service Inc. In 1930, McDermott, Green, and Johnson were GSI employees who purchased the company in 1941. In November 1945, Patrick Haggerty was hired as general manager of the Laboratory and Manufacturing Division. By 1951, the L&M division, with its defense contracts, was growing faster than GSI's Geophysical division. The company was reorganized and initially renamed General Instruments Inc. Because there already existed a firm named General Instrument, the company was renamed Texas Instruments that same year. From 1956 to 1961, Fred Agnew of Dallas, later a Republican member of the Texas House of Representatives, was the Texas Instruments president. Geophysical Service, Inc. became a subsidiary of Texas Instruments. Early in 1988, most of GSI was sold to the Halliburton Company. Texas Instruments exists to create, make and market useful products and services to satisfy the needs of its customers throughout the world. Patrick Haggerty, Texas Instruments Statement of Purpose: Geophysical Service Incorporated in 1930. Clarence Karcher and Eugene McDermott founded Geophysical Service, an early provider of seismic exploration services to the petroleum industry. In 1939, the company reorganized as Coronado Corp., an oil company with Geophysical Service Inc., now as a subsidiary. On December 6, 1941, McDermott, along with three other GSI employees, Eric Johnson, Cecil H. Green, and H.B. Peacock purchased GSI. During World War II, GSI expanded their services to include electronics for the U.S. Army, Signal Corps, and the U.S. Navy. In 1951, the company changed its name to Texas Instruments, GSI, becoming a wholly owned subsidiary of the new company. An early success story for TGSI came in 1965 when GSI was able to monitor the Soviet Union's underground nuclear weapons testing under the ocean, in Vela uniform, a subset of Project Vela, to verify compliance of the Partial Nuclear Test Ban Treaty. Texas Instruments also continued to manufacture equipment for use in the seismic industry, and GSI continued to provide seismic services. After selling GSI, T finally sold the company to Halliburton in 1988, at which point GSI ceased to exist as a separate entity. Defense electronics. Texas Instruments entered the defense electronics market in 1942 with submarine detection equipment, based on the seismic exploration technology previously developed for the oil industry. The division responsible for these products was known at different points in time as the Laboratory and Manufacturing Division, the Apparatus Division, the Equipment Group, and the Defense Systems and Electronics Group. During the early 80s, Texas Instruments instituted a quality program which included jury training, as well as promoting statistical process control, Taguchi methods, and design for Six Sigma. In the late 80s, the company, along with Eastman Kodak and Allied Signal, began involvement with Motorola, institutionalizing Motorola's Six Sigma methodology. Motorola, who originally developed the Six Sigma methodology, began this work in 1982. In 1992, the DSEG division of Texas Instruments' quality improvement efforts were rewarded by winning the Malcolm Baldrige National Quality Award for manufacturing. The following are some of the major programs of the former T Defense Group. Infrared and radar systems. T developed the AAA for infrared search and track in the late 50s and early 60s for the F-4B Phantom for passive scanning of jet engine emissions, but possessed limited capabilities and was eliminated on F-4Ds and later models. In 1956, T began research on infrared technology that led to several line scanner contracts, and with the addition of a second scan mirror, the invention of the first forward-looking infrared in 1963, with production beginning in 1966. In 1972, T invented the common module FLIR concept, greatly reducing cost and allowing reuse of common components. T went on to produce side-looking radar systems, the first terrain-following radar and surveillance radar systems for both the military and FAA. T demonstrated the first solid-state radar called molecular electronics for radar applications. In 1976, T developed a microwave landing system prototype. In 1984, T developed the first inverse synthetic aperture radar. The first single-chip gallium arsenide radar module was developed. In 1991, the Military Microwave Integrated Circuit Program was initiated, a joint effort with Raytheon Missiles and Laser-Guided Bombs. In 1961, T won the Guidance and Control System contract for the Defense Suppression AGM-45 Shrike anti-radiation missile. This led later to the prime on the high-speed anti-radiation missile development contract in 1974 and production in 1981. In 1964, T began development of the first laser guidance system for precision-guided munitions, leading to the Paveway series of laser-guided bombs. The first LGB was the Bolt 117. In 1969, T won the Harpoon Seeker contract. In 1986, T won the Army FGM-148 Javelin Fire and Forget man-portable anti-tank guided missile in a joint venture with Martin Marietta. In 1991, T was awarded the contract for the AGM-154 Joint Standoff Weapon. Military computers because of T's research and development of military temperature-range silicon transistors and integrated circuits. T won contracts for the first IC-based computer for the U.S. Air Force in 1961 and for ICs for the Minuteman missile the following year. In 1968, T developed the data systems for Mariner program. In 1991, T won the F-22 radar and computer development contract. Divestiture to Raytheon. As the defense industry consolidated, T sold its defense business to Raytheon in 1997 for $2.95 billion. The Department of Justice required that Raytheon divest the T monolithic microwave integrated circuit operations after closing the transaction. The TMMIC business accounted for less than $40 million in 1996 revenues, or roughly 2% of the $1.8 billion in total T defense revenues was sold to Triquint Semiconductor, Inc. Raytheon retained its own existing MMIC capabilities and has the right to license T's MMIC technology for use in future product applications from Triquint. Shortly after Raytheon acquired TDSEG, Raytheon then acquired Hughes Aircraft from General Motors. Raytheon then owned T's mercury-cadmium telluride detector business and infrared systems group. In California, it also had Hughes infrared detector and an IR systems business. When again the U.S. government forced Raytheon to divest itself of a duplicate capability, the company kept the TIR systems business and the Hughes detector business. As a result of these acquisitions, these former arch-rivals of T-Systems and Hughes Detectors worked together. Immediately after acquisition, DSEG was known as Raytheon T-Systems. It is now fully integrated into Raytheon and this designation no longer exists. Semiconductors. Early in 1952, Texas Instruments purchased a patent license to produce germanium transistors from Western Electric Co., the manufacturing arm of AT&T, for $25,000, beginning production by the end of the year. On January 1, 1953, Hagerty brought Gordon Teal to the company as a research director. Gordon brought with him his expertise in growing semiconductor crystals. Teal's first assignment was to organize what became T's Central Research Laboratories, which Teal based on his prior experience at Bell Labs. Among his new hires was Willis Adcock, who joined T early in 1953. Adcock, who like Teal was a physical chemist, began leading a small research group focused on the task of fabricating grown junction silicon single crystal small signal transistors. Adcock later became the first T Principal Fellow. First silicon transistor and integrated circuits. On January 26, 1954, M. Tannenbaum al. at Bell Labs created the first workable silicon transistor. This work was reported in the spring of 1954 at the IR Off the Record Conference on Solid-State Devices and later published in the Journal of Applied Physics. 26, 686–691. Working independently in April 1954, Gordon Teal at T created the first commercial silicon transistor and tested it on April 14, 1954. On May 10, 1954, at the Institute of Radio Engineers National Conference on Airborne Electronics, in Dayton, Ohio, Teal also presented a paper, Some Recent Developments in Silicon and Germanium Materials and Devices, at this conference. In 1954, Texas Instruments designed and manufactured the first transistor radio. The Regency TR-1 used germanium transistors, as silicon transistors were much more expensive at the time. This was an effort by Hagerty to increase market demand for transistors. Jack Kilby, an employee at T's Central Research Labs, invented the integrated circuit in 1958. Kilby recorded his initial ideas concerning the integrated circuit in July 1958 and successfully demonstrated the world's first working integrated circuit on September 12, 1958. 6 months later, Robert Noyce of Fairchild Semiconductor independently developed the integrated circuit with integrated interconnect, and is also considered an inventor of the integrated circuit. Kilby won the 2000 Nobel Prize in Physics for his part of the invention of the integrated circuit. Noyce's chip, made at Fairchild, was made of silicon, while Kilby's chip was made of germanium. In 2008 he named its new development laboratory, Kilby Labs, after Jack Kilby. In 2011, Intel, Samsung, LG, St. Ericsson, Huawei's HiSilicon Technologies subsidiary, Via Telecom and 3 other undisclosed chip makers licensed the C2C link specification developed by Arteris Inc. and Texas Instruments. Standard TTL. The 7400 series of transistor logic chips, developed by Texas Instruments in the 1960s, popularized the use of integrated circuits in computer logic. The military-grade version of this was the 5400 series microprocessor. Texas Instruments invented the handheld calculator in 1967 and the single-chip microcomputer in 1971. Was assigned the first patent on a single-chip microprocessor on September 4, 1973. This was disputed by Gilbert Hyatt, formerly of the Microcomputer Company, in August 1990 when he was awarded a patent superseding T's. This was overturned on June 19, 1996 in favor of T. First speech synthesis chip. In 1978, Texas Instruments introduced the first single-chip LPC speech synthesizer. In 1976 T began a feasibility study memory-intensive applications for bubble memory then being developed. They soon focused on speech applications. This resulted in the development the TMC02801 chip linear predictive coding speech synthesizer, which was the first time a single silicon chip had electronically replicated the human voice. This was used in several T commercial products, beginning with Speak and Spell, which was introduced at the Summer Consumer Electronics Show in June 1978. In 2001 T left the speech synthesis business, selling it to Sensory Inc. of Santa Clara, California. Consumer Electronics and Computers. In May 1954, Texas Instruments designed and built a prototype of the world's first transistor radio, and through a partnership with Industrial Development Engineering Associates of Indianapolis, Indiana, the 100% solid-state radio was sold to the public beginning in November of that year. T continued to be active in the consumer electronics market through the 1970s and 1980s. Early on, this also included 2 digital clock models, one for desk, and the other a bedside alarm. From this sprang what became the Time Products division, which made LED watches. Though these LED watches enjoyed early commercial success thanks to excellent quality, it was short-lived due to poor battery life. LEDs were replaced with LCD watches for a short time, but these could not compete because of styling issues, excessive makes and models, and price points. The watches were manufactured in Dallas and then Lubbock, Texas. In 1978, Texas Instruments introduced the first single-chip speech synthesizer, and incorporated it in a product called Speak and Spell, which was later immortalized in the movie E.T. the Extraterrestrial. Several spin-offs, such as the Speak and Read and Speak and Math, were introduced soon thereafter. In 1979, T entered the home computer market with the T99 Cortez, a competitor to such entries as the Apple II, Tandy, Radio Shack TRS-80 and the later Atari 400 and 800s. series and Commodore VIC-20. It discontinued the T99-4A, the sequel to the 99 quarters, in late 1983 amidst an intense price war waged primarily against Commodore. At the 1983 Winterse, T showed models 99 halves and the Compact Computer 40, the latter aimed at professional users. The T Professional ultimately joined the ranks of the many unsuccessful DOS and x86-based, but non-compatible, competitors to the IBM PC. The company for years successfully made and sold PC-compatible laptops before withdrawing from the market and selling its product line to Acer in 1997. Artificial intelligence. Texas Instruments was active in the 1980s in the area of artificial intelligence. In addition to ongoing developments in speech and signal processing and recognition, it developed and sold the Explorer computer family of Lisp machines. For the Explorer, a special 32-bit Lisp microprocessor was developed, which was used in the Explorer 2 and the T Micro Explorer. AI application software developed by T for the Explorer included the Gate Assignment System for United Airlines, described as an artificial intelligence program that captures the combined experience and knowledge of a half-dozen United operations experts in software for the PC. They introduced Personal Consultant, a rule-based expert system development tool and runtime engine, followed by Personal Consultant Plus, written in the Lisp-like language from MIT known as Scheme, and the Natural Language Menu System and L-Menu. Sensors and Controls. Texas Instruments was a major OEM of sensor, control, protection, and RFID products for the automotive, appliance, aircraft, and other industries. The S&C division was headquartered in Attleboro, Massachusetts. In 2006, Bain Capital LLC, a private equity firm, purchased the Sensors and Controls division for $3 billion in cash. The RFID portion of the division remained part of T, transferring to the Application-Specific Products business unit of the Semiconductor division, with the newly formed independent company based in Attleboro taking the name Sensator Technologies. Software. T sold its software division along with its main products such as the IEF to Sterling Software in 1997. It is now part of Computer Associates. T still owns small pieces of software though, such as the software for calculators like T Interactive.